Hey researchers, I'm Andrew from Editverse, and if you've ever felt totally lost trying to pick the right statistical test, you're not alone. I've been there too. Today, I'm sharing a simple, foolproof method that saved me from countless late-night panic sessions. By the end of this video, you'll be confidently choosing the right test without breaking a sweat. Picture this, me sitting at 2 a.m. with a dataset in front of me, wondering, do I need a t-test or ANOVA? Wait, what's a Mann-Whitney again? Sound familiar? Don't worry. By the end of this video, you'll know exactly how to pick the right test every time. Let's make stats simple. To start, answer these 3 questions. 1. What type of data do you have? Categorical, data that fits into groups like yes/no, male/female, or types of treatments. Continuous, measurements like height, weight, or blood pressure. Ordinal, ranked data, like survey responses on a scale of 1 to 5. 2. How many groups are you comparing? 1 group? 2 groups? 3 or more groups? Each setup calls for different tests. 3. Are your data normally distributed? If your data forms a nice bell curve, congrats, you can use parametric tests. If it's skewed or all over the place, non-parametric tests are your friend. I learned this the hard way during my first project. I assumed my survey data was normal and ran a t-test. The results were all over the place. When I checked the distribution later, it was skewed and I had to switch to a Mann-Whitney U-test. Lesson learned, always check normality first. Let's break down these 2 types of tests so you know when to use each. Parametric tests assume your data is normal and that other conditions like equal variances are met. They're powerful and precise when the assumptions hold. Examples include t-tests and ANOVA. Non-parametric tests don't make those assumptions. They work well with skewed data or small sample sizes. They're less precise, but more flexible when things get messy. Think Mann-Whitney U or Kruskal-Wallis. I used to think non-parametric tests were plan B, only for when things went wrong. But in reality, they can be lifesavers. When I analyzed patient satisfaction data, it wasn't normal, and using a Wilcoxon test gave me much more reliable results than a t-test ever could. Now that you know the basics, let's break down the most common tests based on your data type. 4 categorical data tests. Chi-square test. When to use. Comparing frequencies between groups. Example. Are males or females more likely to choose a specific treatment? Key assumption. Each group should have an expected frequency greater than 5. Fisher's exact test. When to use. Small sample sizes, especially in 2 by 2 tables. Example. Comparing success rates in small patient groups. 4 continuous data tests. Independent t-test. When to use. Comparing the means of 2 independent groups. Example. Drug A versus placebo. Key assumption. The data should be normally distributed. Paired t-test. When to use. Before and after measurements within the same group. Example. Measuring blood pressure before and after a new medication. ANOVA. When to use. Comparing the means of 3 or more groups. Example. Comparing effectiveness of multiple treatments. 4 non-parametric alternatives. When your data isn't normal, here's what to use. Mann-Whitney U-test. Use this instead of an independent t-test to compare 2 independent groups. Wilcoxon sign rank test. Use this instead of a paired t-test to compare before and after measurements within the same group. Kruskal-Wallis test. Use this instead of ANOVA when comparing the means of 3 or more groups with non-normal data. Quick recap. First, determine if your data is categorical, continuous, or ordinal. Check how many groups you're comparing. Finally, assess normality and select either parametric or non-parametric tests accordingly. Remember, the right test helps you avoid misleading results and ensures your research conclusions are accurate. Don't be afraid to switch to non-parametric alternatives. They're not a backup plan. They're a smart choice when your data needs flexibility. Thanks for joining me today. If you found this guide useful, be sure to check out more research tools at editverse.com and drop your questions in the comments below. I'd love to help.